Hey there, yesterday we looked at Lego sets. As a population of Lego sets, we gathered a sample. When you are looking at statistics and you realize it's going to be difficult to ask the entire population, and so I'm going to get a sample, what we're going to talk about today is how to make sure you get something called a random sample. So first, let's just review, because we wrote a definition down of what a random sample is. If you look at page 1, get out your spiral notebook right now. Look at page 1, you wrote a definition of random sample. Random sample means a sample where every member of the population had an equal chance of being selected. That doesn't mean they were selected, it means they had an equal chance. I'm going to tell you my Lego sample was not a random sample because I picked Lego sets that I wanted to pick. I wasn't necessarily randomly choosing from everything. So if you're like in the Ninjago area, you had no chance of being selected because I don't really like those sets, so I wasn't going to pick one of those. So we're going to focus today on what is a random sample and how do we recognize, or how do we get a random sample. So get out your spiral notebooks, flip to page 2. Here we go. So here's what I have on my page already. Be careful as you write this down. Here's my title, Random Samples and Predictions. So we're doing a little more than just looking at random samples. I have something written in here, which I'll let you pause and look at in a second. Make sure you've got page number 2 labeled here, so we're keeping track of where we are. Now, before you write this, make sure you count the right number of spaces, because we're going to fill in some of this other area with stuff and you want to make sure you have room. So this is 1, 2, 3, 4, 5, 6. I skipped 6 spaces and started writing this on the 7th line. So it says the senior class president is planning a graduation party. She wants to survey a sample of seniors to find out what kind of party they want. Go ahead and pause if you need more time to write that down and put a little box around it. All right, now that we've gotten that written, I'm going to go like this, and I am going to, just to make sure we're processing this difference between a population and a sample. If she wants to survey a sample of seniors, does that mean she's going to ask every single senior? No, she's not. She doesn't want to go ask every senior. She's decided that's going to be too difficult, so she's just going to get a sample. But we always want to keep in mind, I'm going to come right up here, right underneath the title. Then I'll show you how it goes together in just a second, but I'm going to write population. The population that she is studying, even though she's not going to ask the entire population, the population that this senior class president is studying is all seniors. Oops, I forgot the I. Seniors, S-E-N-I-O-R, all seniors at her school. That's who she is studying. So even though she's not going to ask every single one of them, that's still her population. So I just, for fun, I put it up here, and I'm going to put a little loopy thing around it, and I'm going to draw an arrow right from this straight up to this. It's very important when you're studying this idea of samples and populations that you recognize and wrap your brain around what is the population being studied. Even though we know she's not going to ask them all, what is the population being studied? Now, you ready? I'm going to draw some arrows like this. I'm going to draw one this way, diagonal. And I did that diagonal just over one space. And then I'm going to draw one this way, a diagonal going one space that other way. And then I'm going to write a bunch of words. I'm going to show you those words right now. Okay, so number 1, I put a number 1 here. And I wrote this first. I just came up right underneath population, wrote number 1, and then I wrote this. What if she selects every 10th student as they get off the bus? And then after I wrote that, I drew just kind of these little arcs around it. Okay, because we're going to write more stuff in there. And then I came over here and wrote number 2 on this line and said, what if she asks all of the seniors in her choir class? And then I drew these little arcs around it. You can always pause me if you need more time to get that all written out. And then when you're ready, down here, I'm also going to draw an arrow this way and an arrow this way. Okay. And I'm going to come over here and I'm going to write number 3. I'm skipping a space and writing number 3, skipping a space and writing number 4. And then I'm going to put a bunch more words. All right, here's the words. Number 3 says, what if she puts the seniors' lunch numbers in a hat and picks 100 numbers? There should be a little possessive apostrophe there. And number 4, what if she announces that anyone interested should meet in the library? So the other thing I'm going to do just to finish the setup here is I'm going to count 2 spaces below where I wrote numbers. This should be the 17th space down. I'm going to draw a line across here because we're going to answer some questions under that in a second. But then I'm also going to do my little bubble things around here and around here. Okay. All right. Now let's look at this kind of all together. What are all these what if questions I'm even asking you? Well, this is the main question, and I'm just going to kind of accentuate it by tracing around it in another color. This is the big idea here, is that she's trying to figure out what should the graduation party be. And so not only does she need to survey students, but she needs to figure out a way to survey them, that gets her a random sample. She wants a good representation of seniors. She doesn't want to just pick a certain group that's not going to represent everybody. Not every student is of the same mind. So she wants to not ask everyone, but she wants to pick a sample that represents everyone as best it can. So I'm giving you 4 options here of how she could possibly run this sample. And what I want to know is, do you think these options represent a random sample? Remember, random sample would mean everyone in the population had a chance to be selected. That doesn't mean they all were selected. It means they all had a chance to be selected. So her population is all seniors at her school. So keep this in mind. So if she does number 1 says, what if she selects every 10th student as they get off the bus? I'm going to go through and I'm going to tell you whether or not these are random. I'm going to say random or not random. And then we're going to go back and talk about why. If she does this, selects every 10th student as they get off the bus. So I'm going to tell you right now that this is not random. Okay, be thinking about why that would be. That's not a random sample. Number 2, what if she asks all of the seniors in her choir class? This is also not random. Again, be thinking about why. Question number 3, what if she puts the seniors' lunch numbers in a hat and picks 100 numbers? This is random. That will get her a random sample. This will not be a random sample. This will not be a random sample. This will be a random sample. And question number 4 says, what if she announces that anyone interested should meet in the library? This one surprises some people, but this is also not going to lead to a random sample. So everybody got that? You wrote down not random or random? Take a look at those and see if you can figure out why. I'm going to show you the reasons why right now. Okay, let's read these and make sure we're really clear on this. See that stuff I wrote in green? You need to write it down, but also listen while I explain here. Number 1 is not random. The idea of a random sample is every member of the population, which is supposed to be all the seniors at the school, have a chance of being selected. So this is not random because only students that ride the bus have a chance to be selected. Is that going to include all seniors? No. In fact, most of the people that ride a bus are not seniors. A lot of seniors drive themselves. Okay, so this is absolutely not random because only students that ride the bus have a chance, not all seniors. This is absolutely not random because only students that are in choir class have a chance to be selected. Is that going to be every senior? No, of course not. Okay, only students that are in choir class have a chance to be selected, not a random sample. Number 3 is the big winner here, and I'm even going to put some arrows pointing to it. This is the way, senior class president. This is how you want to get your sample. Why? Because it allows every senior a chance to be selected. Every senior has a lunch number or student ID number. So if you just take all those numbers and you put them all in a hat and you draw out 100 names, then every student did not get selected, but every senior had a chance to be selected, which is the definition of a random sample. And number 4 was not random, simply because if you do things voluntarily, if you just say, come if you want to, it never ends up being a good representation just because a lot of students that would respond or have ideas wouldn't show up to that. Or maybe if you have an announcement, maybe they're in certain class periods that they don't hear the announcement or whatever. Not every senior is going to have a chance to be selected. Voluntary stuff where you ask for volunteers is not a good way to draw a sample. So let's say that this is what the senior class president did. She put all the lunch numbers in a hat and she randomly drew out 100 names. So she has her sample now. And she asked these students what type of party they want. And so we're going to say she did this one. I'm going to draw an arrow down here and I'm going to say survey results. So now that the senior class president has decided this is the best way to get a random sample, this is what she did. She drew 100 names and she asked them, which type of party do you want? But she didn't just ask them this big open-ended question because, you know, we can't just do anything. So she already had approved 3 ideas and she asked these students, which one do you want? So we're going to make a table here. It's going to be 2 lines long. So I'm going to draw a line like that. I'm going to put right here, party type. And I'm going to draw another line there. I'm going to tell you the 3 party types. I'm going to write them across here. Party type number 1, first option was a pool party. That was an approved senior graduating party, a pool party. Option number 2, see, I put another line. Option number 2, here was another approved one, is they could go on a one-night camping trip for a graduation party. And option number 3 was what we're going to call a gym all-nighter, where they just hung out in the school gym for an all-nighter. Had some games, had some movies, different stuff like that. Okay, so now I'm going to draw lines this way. And I'm going to show you the results of that survey. All right, and I'm going to just draw this part in a different color just because you know I like to. All right, so here were the survey results. I'm going to tell you down here, this one is number of votes. So remember what she did is she put all the senior lunch numbers in a hat. She drew 100 names and asked those 100 seniors, which is now a good representation of the school because it was a random sample. She asked them, would you rather do a pool party, camping trip, or a gym all-nighter? And they voted, and these were the results. 32 of those seniors wanted a pool party. 43 of them wanted a camping trip, and 25 of them wanted an all-nighter in the gym. Now, camping trip wins, so maybe that's what the senior class president would go with. But I'm actually going to ask you a series of questions about this. What we now have here is we have some sample data. We did a survey, and we now have some data. And the other part of this, your title said random samples and predictions. So with this, I want you to understand what a random sample is, the idea of, did you ask in a way where every member of the population actually had a chance of being selected? So that's a part of it. But then also, once you have your random sample, what can you do with it? All right, so I'm going to write down some questions that I need you to answer. And I'm first going to number for you. So I'm going to skip a line so we can get this set up, and then I'll show you what you need to write. We're going to put number 1 right here. Right underneath it is going to be number 2. And that is going to take up the rest of it, which we're going to do A, B, and C. Okay, let me show you what the questions are so that you can get them written down. Okay, question number 1 is, what is the sample size? So first, just write that down. Question number 2, I started it for you. It says, if there are 450 seniors in her graduating class, how many can she expect to choose? And I'm going to write more in a minute. And yes, you got to write all this down, because if future you tries to look back at this page and all you did was write down the answers, it wouldn't make any sense whatsoever. So you need to write down the questions. Since we're formatting it in our own notebook here, you got to write it down. And we're going to do this. We're going to go through each of them. So I'm going to put an A right here, and I'm going to say, okay, pool party. How many could she expect to choose pool party? And then I'm going to skip 2 spaces and then put B. How many can she expect to choose a camping trip? And then I'm going to skip 2 spaces and put C. How many will choose the gym all-nighter. And we are going to use math that we are already familiar with to answer these questions. But this is the beauty of getting a sample and getting data from a sample is we then use the sample to make predictions about the entire population. Even though we didn't ask the entire population because that sounded like too much work, we can use it to make predictions. All right, so let's give this a try. First of all, what is the sample size? What does that mean? Sample size is how many people did she ask? Oh, she asked 100 people. That's actually a thing that we know, right? We said she drew 100 names from the hat, but even if we hadn't said that, all we'd have to do is add up all these numbers and we would know our sample size. She asked 100 people. All right, if she asked 100 people, let's start with the sample here. How many people in the sample said they would want the pool party? Well, in the sample, it was 32 out of 100, right? In the sample, 32 out of 100 said that. So we're saying if this is what happened in the sample, we're going to use a proportion just like we've done lots of times in this class. If this is what happened in the sample, we're saying what would happen in the population, which is out of 450. This is what happened in the sample. What do we think will happen in the population? Now to solve this, we're going to cross multiply. So in our calculator, we're going to go 32 times 450, right? We all remember cross multiplying. We've used it a lot. 14,400 equals 100x. We divide both sides by 100, divide by 100, and we could expect 144 seniors to choose the pool party. If our sample is an accurate record, now, does that mean if I went out and asked every senior that exactly 144 would say pool party? No, probably not. But it should be a pretty close prediction based on our sample, what our sample said. Okay, camping trip, what happened in the sample? Well, 43 out of 100 said they would choose camping trip in the sample. So what would that be out of 450? Cross multiply and solve. 43 times 450 is 19,350 equals 100x. Divide by 100, divide by 100. And we would expect, well, this says 193.5 seniors. That's where it becomes really clear that, yeah, this is just a prediction and not necessarily accurate because there's no such thing as half of a senior. They're a whole person, no matter what. All right, and the gym all-nighter in our sample, we said 25 out of 100. So what would that be in the population? So you start with what happened in the sample. Okay, let's use that to make a prediction what will happen out of the population. 25 times 450 is 11,250 equals 100x. Divide by 100, divide by 100, and that is 112.5 seniors. And now the senior class president can use this data to make a decision. All right, give your Canvas quiz a try. If you have any questions, please let me know.